we are going to discuss time and length scales that we are going to encounter in a reactor. In the previous video, we have seen the pellet, the pore, the particle, the active site in relation to the reactor. So let us scale them in terms of their dimensions, in terms of the time scales of the events that take place. What are those processes, which equations we are going to solve, and what are our examples? All right, now first of all, our dimensions of the reactor, if you remember, was of meter scale. The dimensions of the pellet was of millimeter scale, or 10 to minus 3 meters scale. The dimensions of the site of the order of nanometer scale, or 10 to minus 9 meter scale. Coincidentally, we have similar time scales of the events that are taking place on the site, on the pellet, and in the reactor. Now, on the site, the processes that are taking place are bond-making, bond-breaking nature. And those events take place on time scales that are less than 10 to minus 9 seconds. On the pellet scale, the events that take place are of the nature of molecular migrations or diffusion. And the time scales of these processes are of the order of 10 to the minus 3 seconds. On the reactor scale, we have transport processes at the large scale. We have hydrodynamics. We have heat transfer. And we have macroscopic scale mass transfer issues. And of course, the time scales that are relevant in the reactor are of the order of second time scales. Now, which equations do we need to solve in order to have a grip of these events? Now, bond-making, bond-breaking events require electron transfer, and we have to solve Schrödinger's wave equation. All right. And of course, it's one of its many approximations. In the pellet scale, when we are bound to understand the molecular motions and the transport events, we have to solve species conservations. In the reactor scale, in addition to the species conservation equation. We need to solve the conservation of energy and conservation of momentum equations wherever and whenever needed. Now, let me give an example to the site, to the catalytic site, catalytic active site. It is, for example, platinum or platinum rhodium catalyst that cleans up the exhaust emissions, or it is the enzymes in biological systems that initiate chemical conversions. A typical pellet is the monolith, where you have those platinum or platinum rhodium catalysts. It has a millimetric openings, multi-channel system, or it is a spherical pellet which has a millimetric diameter with impregnated catalytically active materials. So we have millimetric scales. Corresponding example for the biological systems are, for example, organelles. And of course, at the reactor scale, our example is a typical industrial scale reactor. Or your exhaust muffler that resides underneath of your car. The corresponding reactor domain for the biological systems can be considered as a cell, a plant cell, or an animal cell. So if you summarize, we are going to learn to relate problems that are relevant at nanometer scale to the operations that are going to take place in meter scale. We're going to learn to relate events that are taking place at time frames shorter than a nanosecond to the macroscopic events that are taking place on the order of seconds. In doing so, we will relate the output of the Schrödinger's wave equation to the output of the conservation laws. So this is going to be the frame of the semester of this course.